Hello, my name is Doug Picklick. I'm the editor of HPAC Magazine, publisher of Modern Hydronics, and the leading publication and resource for mechanical contracting businesses across Canada. Welcome to our free webinar on the topic of combi boilers, non-combi boilers, when and where. We have two hydronic industry experts here today to speak about their experiences with combination boilers, those devices that serve domestic hot water and space heating requirements for residential applications. Together, they'll share their advice on when and where combi systems make sense in today's market. Before we proceed, I would like to take a minute to make you aware of another free webinar series beginning later this month. Part 1 will take place on Tuesday, September 22nd at 3 p.m. Eastern Time. It's hydronics industry expert John Siegenthaler will be presenting on the topic of air-to-water heat pumps, a session being presented by Cleffi Hydronic Systems. Part 2 of the series will be happening in November, and you can find out more information on our website at hpacmag.com. Also, I have some breaking news to share. We're happy to announce that our next Modern Hydronics Summit will be a virtual event taking place in March 2021. It'll be featuring all of the hydronic experts you've come out to see over the past 8 years at our live events, only now in a virtual setting. So stay tuned for more details to come on this exciting event. Back to today's agenda. First, I'd like to give a quick introduction to our speakers. Steve Goldie is a regular contributor to HPAC Magazine. Steve learned his trade from his father while working as a plumber in the family business. After 21 years in the field, he joined the wholesale side of the business in 2002 and is currently a hydronic specialist with the Next Supply. Mathew Pottins is the group leader for residential products with Aquastat Canada. Matt has been in technical advisory roles with Aquastat since 2012, working primarily with residential hydronic installers and service technicians. Steve and Matthew will lead the discussion today and speak with each other for about 30 minutes. Then we'll open the floor to your questions, so please feel free at any time to type in your questions into the question box on your screen, and we'll try to get to all of them and wrap up this entire webinar within 45 minutes. This webinar is being recorded, so you will be able to review anything you miss at a later date. Without any further ado, I present Steve Goldie. Take it away, Steve.
Thanks, Doug. How you doing, Matt?
Good, thanks.
So combi boilers. Combi boilers are very much in demand in our marketplace, as you know. The advantage of a combi boiler is doing both heating and domestic water, and there's been lots of attempts at designing something that works well to do this application over the years. In the early days, 20 odd years ago or more, the combis that were available were like on the screen here. This is one I was actually involved in replacing this one. This is a storage-based combi system where you had primarily a hot water tank that then you took the domestic hot water and stored energy in that and put that through a heat exchanger to do your closed loop space heating. This example was one that was, I think it was about 110,000, 120,000 BTUs range. So it gave you lots of recovery, lots of hot water, and a decent amount of space heating, so it could do most single family homes. This example here shows one of the things that makes a combi very desirable is they don't take up a lot of space. Now people get carried away with that, like in this case, where they literally built it into a closet, which made it servicing it very difficult. And when they had to replace it, they had to take the whole closet down. But that's definitely one of the big, large appeals of having a combi appliance is that it's a space-saving appliance. Now, I guess we're going to discuss is it always the best option? What do you think? I mean, you've seen lots of combis, Matt. What do you think?
Yeah, I really like the idea of the combi. I actually really like the idea of this type of combi. I mean, the combis now are sort of shrinking in size, but the larger size combi, I mean, at the end of the day, it's sort of taking up the same footprint, even just if the combi's
Yeah.
in a smaller jacket, it's sort of still taking up the same footprint. But in this case, you sort of have that extra mass to deal with that larger volume of water that you might need for extra showers and kitchens and whatnot. So although combis are shrinking in size, I actually kind of like this style, and I think that we might actually get back to it because it's sort of like the cell phone, right? It started as this big, huge device and sort of shrank down to this like smaller little device. And now the cell phones are growing again. I think that's sort of what you're going to see with the combi market, and there's a lot of opportunity with it.
I'm glad to hear you say that because I've always been I've always been a fan of storage. I think the market really wants to have a small box on the wall, like the wall hung combis that we see. From a water heating point of view, people love the tankless water heater to replace the tank, but I kind of agree with you. Agree with you. I think it's smaller and fits on a wall, but at the end of the day, it takes up the same footprint because you're not really using that space underneath it. So whether it's standing on the floor or hanging on the wall, really it's taking up the same amount of space. But
Yeah,
I'm glad to hear you say that because I do like to see storage for both hot water and from a heating point of view. I like storage because that gives you a bit of a buffer, and we can talk about buffer tanks down the road as well, and they're definitely have a big place. Now this here picture is what replaced that previous unit. So the previous unit was a older technology of non-condensing, so not as efficient. There you go, with the burner in the bottom. It was a tank-in-tank type of heat exchanger design. Whereas the other one here, if you go forward, this has got like a mini boiler inside and a small storage tank. So you've got a small indirect tank, I think 20 or 30 gallons, and then you've got a boiler inside. So again, everything's compact. It can go into a closet. And this will do space heating up to about, I think, again, 125,000, 150,000 BTUs worth of space heating, modulating, condensing appliance, so much more efficient than the previous versions. And with that storage and capacity in there, you're going to have decent recovery with 125,000 BTUs of domestic, but you've also got 25 or 30 gallons of storage um, to give you a bit of a head start and a bit of dump load. So I'm with you, Matt. I like this type of combi.
yeah,
Um,
and there's like, yeah, no, sorry, I was just gonna say, I see more, I'm seeing more and more often that we're installing combi boilers, and then we're realizing that, you know, we're the flow is not keeping up to the demands of the house. So we're actually adding in like an external 30-gallon storage tank or something like that to create a recirculation and mass in the system. And I feel like that's like gonna soon be the new norm, unless it's already built into the machine like this.
right.
So, it's not the combi boiler saves a lot of space and it does an excellent job. If it's sized properly, it can keep up with the house no problem by itself. But if it's, undersized for whatever reason, because that's just what, the designer or the house requires, there's often times that you have to stick that extra external storage tank in place to help out with that system.
Yeah, I think that's like with the tankless water heaters in the early days, people would install them because again, the manufacturers did a good job of selling them, saying, like, why keep all this hot water stored overnight when you can only heat it up as you use it? Well, that sounds good, and that makes sense to a degree. But if you're not storing hot water, you need a lot of firepower to make enough hot water to make it on demand. And
Yeah,
this, so you need about 33,000 BTUs for every gallon a minute at showering temperature. So with 40-degree incoming water, 65-degree delta T, that's going to give you 105-degree water, shower water, which is about what most people shower at. That takes 33,000 BTUs per gallon per minute. So one shower head, 2.5 to 3 gallons a minute, you're looking at, that's 100,000 BTUs. Now, if you want to do 2 showers, you're looking at 200,000 BTUs. So it's no accident that the tankless water heaters are all sized. What are they sized at? They're all sized about 200,000 BTUs, so that we can do that
right.
2 gallon a minute, hit that 2 gallon a minute mark, or 2 shower head mark. But
Yeah,
a combi boiler is in effect a boiler for space heating, but also an on-demand, a wall-hung combi boiler without storage is in effect a tankless water heater in a sense, is not mechanically, but it's doing the
yeah,
same thing, heating your water on demand instantaneously. So it needs all
yeah.
that firepower. It needs to do that. And if we go to the next page, I think we've got a picture of one. Doug, can we move to the next slide? Oh,
Yeah,
no,
so
this is what
no,
you're talking about.
this was an example of a case where it was an older house, but it was completely newly renovated, and it had, you know, newly renovated down to the studs. So all new insulation, all new drywall, all new everything. So we stuck in a smaller combi unit. I think this was 110,000 BTUs. So the heating side was great. The heating side kept up no problem because the R value or the heat loss of the house was very minimal. But because it had more, it required more flow, we had to stick in this external storage tank, which you can see at the bottom there, and that
Right.
actually did the trick.
On the domestic side, you needed more
On the
flow.
domestic side, yeah. So that did the trick, and it satisfied the house. So this actually was an attic where, and I guess this is the pros of the combi is that, you know, these newly built or newly renovated houses are giving us, you know, a fraction of a space for our mechanical rooms.
Yeah.
That's the desire of the combi, right? So we stick in these combis, and you know, in this case, a 200,000 BTU combi would have probably worked out well, but it would have on the domestic side, but would have been too many BTUs on the heating side. So
Right.
it's like like a love-hate relationship, right? It needs to be sized properly.
That's right, and that's the point you make about the discrepancy in size of your heating load and your domestic load is a good point, because we need a lot of firepower to make that hot water on demand, but our buildings are much more tight now. Our heat loads are lower in many cases, so we need the firepower for the domestic. We don't necessarily need that firepower for heating, so we run into issues. Are we oversized on heating? Are we going to be short cycling? But the new boilers, the modulations come a long way. Like 10-to-1 turn down rate on modulation is pretty standard now. So a 200,000 BTU boiler can modulate as low as 20,000 to meet a heat load. So
Right.
so that's great, but still too big to do a lot of the micro loads if you're doing multi-zoning in a house. But they certainly come away. Can we see the next slide now? So there we go. That's a much neater install. You recognize that make, don't you, Matt?
Yeah, so in this case, what we did, we took out a really large older boiler that was 100,000 BTUs or something along those lines, and we took out the storage tank and we just put a combi boiler, and you can see how much neater it is. You know, these older 100,000 BTU boilers are these ships, right? So to take that out and put in a combi, and now we have all sorts of space for storage, and you know, you could potentially, depending on the mechanical rooms that they used to give you, right? These massive rooms that they used to give you, not like today, you could, put, an office in there. You could build up a couple walls, put an office. You could use it for storage. You could do all sorts of different things. So in this case, we did an excellent job, and we took out that old boiler, took out that old indirect, or not indirect tank, that old water heater. I think it was an electric water heater. And we put this combi in, and I mean, you can see from the picture, it looks fantastic. So
nice, neat job.
yeah. So those, I mean, that's an advantage of the combi, right?
Yeah, everybody wants to have a box on the wall that can do everything, and we have appliances that can not do everything, obviously, but they can do a good job of domestic water heating. They can do a good job of heating. My argument is, are they going to do the best job at all of those things? And I'd say no, they're not necessarily going to do the best job. If I've got all the money and I've got all the space and I can design my perfect boiler room, I'm going to have a boiler, I'm going to have an indirect hot water tank with decent storage, and I'm going to have a buffer tank so that I can have manage all my micro loads, and I'm not going to have to short cycle that boiler. But the reality is, we do jobs like that, and there's general contractors and homeowners who see the value in giving the mechanical contractor a boiler room or a mechanical room that's got the space to do all of those things.
Yeah.
But that happens, but more often than not, they want to do everything, and they give you a little, not much bigger than a bread box to do it in. So that's the challenge that we're facing. Like the demands of what they want their system. They want to do snow melt. They want to do heating. They want to do domestic. They want to have car washes for showers and have all the hot water in the world. They want to have all these things, and they say, well, here's the little closet that we're going to give you to put all that equipment in and make it work.
Yeah, it's funny. I've been in a lot of houses. In Toronto, we're really tight for space. So I've been in a lot of houses where it's like they're built really vertical, but there's, 2 laundry rooms, right? But there's only one tiny little mechanical room. So it's like
how many bathrooms?
yeah. So it's like I need to clean my clothes on 2 different floors, but I need to heat from only one little box and
Little
space
tiny
in the
box.
corner. And you can't really blame too many people from trying to cover the heating load, cover the domestic load, and it just sometimes doesn't work out as great as you would hope it would. But there's always
That's
ways. I
right.
mean, everything is application specific, right? So every house requires
Absolutely.
a different thing.
Yeah, and I think that's the key is matching understanding what the application is and matching the right product and managing the expectations of the end user. Because I think there's a lot of misunderstanding still specifically about domestic hot water production. And again, the perception is a little tankless in a wall can do all the hot water you need forever and ever and ever. And uh, it can at a fixed flow rate, but if you've got a big multi-flow shower head that's got 5, body sprays and a big rainfall head that's, pumping out 8, 9, 10 gallons a minute, you're not going to get that from a tankless
Yeah.
or a small on-demand combi.
I would also say, in some of the smaller homes where you only have maybe one bathroom a full bathroom and a half bathroom or something like that, a 3-piece bathroom, where you don't actually need that 200,000 of BTUs. You can use a smaller combi, like a 110,000 BTU combi or something like that. So it's also important to not oversize but not undersize, right? So there's
Absolutely.
two different ways to look at it.
Again, it's about managing expectations.
Yeah,
110, I'm a little bit, I'm scared of that because I think, well, 110, you're not going to get a lot of hot water at that. But again, 33,000 BTUs to get 1 gallon a minute at 105-degree water, you're going to get 3 gallons a minute. So, just a little bit better than 3 gallons a minute of that. Now, if your customer understands that, and they don't have the big multi-flow shower head, they're saying, look, you can have a shower. You can put but you're not going to put your laundry on, your dishwasher on, and do the shower at the same time. That's
exactly.
probably acceptable to a lot of people, as
Yeah,
long as they know going in. So it's just a matter of, again, make sure that they understand what can it do and what can it do. I
yeah,
can give you that shower all day long. If you've got one bathroom and you've got 2 sets of triplets, and they're going to be marching in and out of that shower, one after the other, that'll do it all day long.
also just good luck to you in general if you have 2 sets of
Well,
triplets.
yeah, yeah. But if you've got one teenage daughter who likes to have an hour-long shower, fill her boots. I'll give her that, and she can have that shower for 2 hours if she wants.
Yeah, totally,
But
totally.
if you want to do that and throw the laundry on and do some other things at the same time, you're not going to get away with that with 110. But as
Yeah,
long as the expectations are understood and met, then yeah, we can do all sorts of things.
yeah. So and I'll just cover some of the advantages on this slide here. So
Oh yeah.
uh, some of the things that obviously we know about are we combine the heating and the hot water into one box, which is very appealing to a lot of different houses and homeowners. They're compact, so they create a lot of different space, like we saw in that previous slide where we took out 2 very large units, and now we have, a lot of space for other things in that mechanical room if needed. And they're very efficient, right? Because we're running at potentially 95% efficiency on the heating side. On the
Mhm.
water side, it's a little bit lower, but still more efficient than what you would probably have in there or what you had in there previously. And on-demand hot water, so you can run hot water endlessly, right? If you're just taking a shower and you're just sitting there, you can run that hot water continuously. You're not going to run out of hot water. So that's a nice little feature. And also something I just wanted to touch on too was in a case where you're looking at maybe putting an addition onto your house, or you're looking at maybe moving into the hydronics world from your forced air, your furnace in your house. It's an easy change from a furnace in a tank to a combi boiler with an air handler. And then it gives
Right.
you the ability to do extra things in the future.
Yeah, yeah, I can see that. Now, I noticed you stayed away from that word instant hot water, and you said
Yeah,
on demand because instant gets you in trouble because when you
yeah,
say instant, people want to turn the tap on and boom, there's instantly hot water there, and we know that's not how it works.
yeah,
Which brings up the point of recirc.
yeah,
And if we go to challenges, meeting hot water demand, a high hot water demand of again that big dump load. You've got a big soaker tub with a Roman filler that flows at 5 gallons a minute, 6 gallons a minute, you might be stressed. You got the big, large flow shower head, you might be stressed with an on-demand system. But again, going back to the instant hot water, recirc is something that is a struggle to do if you don't have any storage. If you're making your water on demand and they're working off of a flow switch, if you want to have a recirc line, that means your domestic hot water is flowing all the time. That means your boiler or your on-demand water portion of the boiler is going to be coming off and running constantly, which is nobody wants. That's not efficient. It's not good for the equipment. It's not good for anybody. So adding a little bit of storage makes that work better. And some of the manufacturers are starting to look at that. The challenge is more complex setup. I don't know if they're really a more complex setup. I guess you got to make sure that, again, they're sized properly and that you're setting them up properly. No, either way. No heat also means no hot water. If you're doing a combi unit, one box is doing everything. So if that one box breaks down, you don't have hot water or you don't have heat. So that people look at that. I run into this all the time and say, well, I don't want to put all my eggs in one basket. If it breaks down, then I'm kind of screwed for both hot water and both heat. My argument is like, well, if my hot water heater breaks down, I want to get that fixed right away because I don't want to be without hot water. If I'm in the heating season and my heating breaks down, I want to fix that right away because I don't want to be without heat. So to me, it's like, okay, I got two things I need to fix, or I have one thing I need to fix. So to me, that's not really a challenge. I think that it's just, again, explaining it and making sure the expectations are understood and met.
Yeah, I like that. I think that should be said more often too. Like I think people are so afraid of, I got it in one box and it's going to break down. But I like the way you said that. I think that should be said more often.
Yeah, if it breaks down, you got to fix it, and you're going to do that whether it's doing one thing or two things. I'm not going to say, well, it's only a hot water. I can get to that next month. No, you're not going to have a happy wife when she gets up and can't have a hot shower. So you got to fix it right away. And if I've got one thing to fix, to me that's actually an advantage, not a challenge. But I know a lot of people will sell against them, saying, "Wow, that's a problem. You don't want to do that." So
great point.
Fewer control for more complex setups. I guess it's saying there that and some of the boilers that are boilers only have a lot of great controls in them, and you can do multi-zones off them on the heating side. And the combis are a little bit more basic where you're not really doing that. But again, most of the time for our jobs, those additional controls are external to the boiler anyway. So I don't see that particularly as a huge challenge, but some people may argue.
That was one of the things I threw out there just because, like with the manufacturer that we work with, with the premium boilers, there's a lot of stuff built in where you have like multiple thermostat connections, domestic connections, things like that. With the combi, it's usually just one kind of connection, right? So you can't, just like you said, like you can't really do multi-zones off of it unless you have like an external control, which is fine. You can buy an external control, but it's just not built into the unit typically.
Yeah, it's a fair point. There's a little bit more available on a boiler only. I find that most people aren't taking advantage of those features anyway. But
I don't disagree with that.
Yeah. So key takeaway, I think this is a key takeaway for not just in this topic, but for so many topics. Have a clear understanding of the application and your ability to meet the expectations of the end user. And unfortunately, I think this is where things do fall down. I think that we either don't do a good enough job of explaining the limitations of whatever equipment it is that we're selling, or people want to sell good news. They want to promise the world, and so, oh yeah, this will give you all water. And I fight this all the time. Oh, you'll never run out of hot water. I hate going in the car. Well, I shouldn't say I hate it. I don't mind going in there, but I hear this all the time. Oh, this guy told me I'll never run out of hot water. I said, oh really? Okay, well, let's go around and turn all the taps on and see if we can run out of hot water. I guarantee you I can run out of hot water in any one of those houses. So again, how are we explaining it? How are we qualifying it? So yes, you can you can have a shower all day long in the right circumstances. Just qualify that.
I also think I would just like to reiterate the one point on the last slide. Can we just go back for 1 second? If you're walking into a house where the furnace is broken down and the tank is going to need repair in the future, don't be afraid to offer that combi, right? Like that combi boiler might be a little bit more expensive just at the forefront, but in the long run, it will be probably a more efficient system. And personally, we're seeing that as a growth market for hydronics and for combis. So I just want to emphasize that point, and that just because you're dealing with air to start doesn't mean you have to end up with air in the end.
Absolutely.
So,
Well, and I think another, now we're back to this slide, I think in the advantages column there, economic, the combis, especially the smaller wall hung combis that have become available in the last couple of years, it's astonishing how the price point has come down. And you can get a combi that will do both your domestic and your heating for really only $200 or $300 more than the boiler only. So it does create great opportunities in the marketplace for someone who wants to sell that advantage. And it's, you know, I 2 years ago, 3 years ago, most people who know me know I'm not a big fan of tankless. I'm not a big fan of on demand. That's not completely changed. I still would prefer storage, but the products that are available now, the appliances that are available now do a much better job than 10 years ago. And I definitely see that there's a place for that wall hung combi in our marketplace. Again, qualifying it as long as the expectations are properly explained and understood.
Yeah, I agree.
Okay, guys, I think we've received a number of questions coming in.
Okay.
And if you guys are ready, I'm going to start reading out some of these questions. Well, Andy says buffering management is always a good idea. How many liters per kilowatt of heating would you recommend for the average 200 MBTU combi boilers?
So you're talking about, I think he's asking about how we would size a buffer tank.
Heating storage, I mean. Heating
storage.
storage, I meant. Does that make sense?
Yeah, so the heating storage would be a buffer tank.
Yeah, how many liters would you recommend for average
really
200?
Yeah, I would size buffer tanks based on the difference between what your smallest load is and your minimum firing rate. So if you've got a modulating boiler that's 200,000 BTUs and it can modulate down to 20,000 BTUs, so your lowest firing rate is 20,000 BTUs. And if you've got a zone in your house that might be, maybe your smallest zone that might be calling is 5,000 BTUs. So you've got a 5,000 BTU load potentially, that's the only thing calling, and you've got a 20,000 BTU minimum firing rate. So now if you don't have a buffer tank and your boiler is just turning on as soon as the thermostat comes on, it's going to fire at 20,000 BTU, it's going to make more heat, 4 times as much heat as we can take away. So that's where you need a buffer tank. And you would size it based on that difference load. So then the next part of the formula is, okay, how long do I want my boiler to be off before it cycles on again? And so it's a pretty easy calculation to figure out, okay, how many gallons I would need. In a case like that, I would have at least a 30-gallon buffer tank in a job like that. So, and that's a pretty typical scenario where you've got your smallest zones might be 5,000 or 6,000 BTUs. Your smallest firing rates maybe 18,000, 20,000 BTUs. So in that type of application, a 30-gallon buffer tank is a good starting place.
I was going to say the most common buffer tank that we usually see go out the door is about a 30-gallon when you're dealing with like individual boilers, individual residential dwellings.
Yeah, I'm a huge fan of buffer tanks. And that's a whole different topic, but and in our industry, people like to size bigger is better, and bigger is not better for most things. With a buffer tank, bigger is better. So
Okay.
30 is good size, 50 is even better.
Nice. Sahar asks, can combi boilers be utilized in small office buildings or in general small public buildings?
Absolutely. Again, it's managing your expectations. If you know what your load is, and often public buildings don't have a lot of domestic demand. They may have some wash hands, hand wash sinks. Maybe probably is not a lot of shower loads, not a lot of big dump loads. So your domestic water load may actually be pretty small. Now they may be stretched out, so you want to do resource, in which case you probably want to have some storage. So,
yeah,
Matt, what do you think?
No, I was going to agree. I think it's a great application for combis because just like you said, there's not really a large domestic load in an office building, right? Like there's a washroom, maybe 2 washrooms, and you're just quickly washing your hands with hot water. That's really the most you're going to do. Now, you probably wouldn't put it in like, you wouldn't put it in a gym where people are going to go in and change and shower, unless of course you had some sort of external storage. But just a general office building, I think, would be fine.
Absolutely.
Okay, very good. We had another question along those lines. And then we have a question from Bill. If you're using a storage tank for domestic on a combi setup, what additional piping, pumps, and controls are required? The same question for using a buffer tank in a combi setup. Thank you.
Okay, Matt,
Yeah.
you want to take this one or you want?
So no, I was just gonna say, you can carry on after me, I guess. So I was just gonna say, for the external storage tank on the combi, you need a pump to pump back into the plate heat exchanger that would be inside the combi. You'd also need an Aquastat to actually activate that pump to say, okay, I'm running enough hot water inside the storage tank. Now I have to activate my pump to push water into the plate heat exchanger and activate the flow switch within the combi to replenish the storage tank. So that would be some components, and then a mixing valve most likely on top of the storage tank itself.
As soon as you're doing storage, then you're going to be storing the water potentially higher than, you should be storing at least 140 to make sure you're taking care of Legionella. And in that case, you need to have a mixing valve on that side. I would also add, that's the common way to do it, where you're putting, so typically the domestic would run through the heat exchanger, the flow would trigger the flow switch to bring the boiler on and heat up your water, and off you go. Now with Matt's situation, you're gonna pipe your in and out from your tank, and now we're gonna put a bronze pump to circulate the water from the tank to the combi. And when the Aquastat kicks on, it turns on that pump, and that activates your flow switch and activates your boiler to heat up the water in the tank. And that's a very common way to do it and a good way to do it. There's also another way. Sometimes you can just simply pipe it in series. So you're pumping your hot water into your boiler. Your on-demand boiler is going to make your hot water, then it flows into the tank. You use an electric tank. You can actually use an electric tank as now a storage tank that you can connect it as an electric tank. So you're getting the efficiency of the boiler. So when you're drawing water, the boiler with its high efficiency is making the bulk of that hot water. And now you're just storing it in a little tank that can now, the electric, all it's going to do is maintain that temperature in the tank. And that now lets you do your recirc line from the tank if you want to do that. So there's a couple ways to do it. That way, that second way doesn't require an additional pump.
Okay. Ead asks, do you still need an expansion tank when using a combi boiler?
Definitely.
Absolutely.
On the heating side, for sure.
Yes.
And most likely on the domestic side as well.
Yeah, on the heating side, you still have a closed loop heating system, so you're absolutely going to need all the same components you need on a regular heating system. Expansion tank, water makeup valve, all those things you're going to need. Filtering, magnetic filters, I'm a big fan of. That's all. That's all going to be the same. On the domestic side, again, you're not necessarily storing water, so you shouldn't need an expansion tank on the domestic side. You're heating it up as you use it, and if you're using it, there's an open tap, so it's not a closed system anymore. But as soon as you put a little tank in there, if there's a check valve on your inlet, then you absolutely need a potable expansion tank.
The check valve is a big deal. So if there's a check valve, you need that expansion tank on the domestic side.
Yeah.
Okay. Steve, this is coming from Doug. Steve, the problem I have found is without storage, the system loses efficiency when you have short draws, like a cup of hot water.
That's an excellent point. And this has always been one of my issues with on-demand or tankless water heaters. They've been sold as being much more efficient because their combustion efficiency is better than a hot water tank. Now, that's not hard because the regular conventional hot water tank is about the most inefficient appliance we've in existence. They're horrible. And that goes for power vent too. They're even worse. People think power vent's more efficient. No, they're not. They're crap. They're garbage. Not being said,
how you really feel about them.
But the efficiency comes from lots of different places. And one of the things that whether we're talking about a car or we're talking about a boiler or a water heater, your combustion efficiency happens when you're running. You've got a sort of a stable state, and that's when, if you're doing a combustion analysis, You don't just flip it on, stick your analyzer in there and walk away. You get the thing running, you get it hot, you get it running stable, and that's when you do your test, because that's when you're going to get your efficiency. So short cycling, as I've often called it, is a dirty little secret of our industry. That's why I'm a big fan of buffer tanks. I don't want my appliance, whether it's doing domestic or heating, I don't want it to come on, off, on, off, on, off all the time, because that's like the picture I always give is highway driving compared to city driving in your car. If your car's stopping and starting, stopping and starting, what happens to your fuel mileage? Boom, drops. Same thing with an appliance. If your hot water heater is coming on, off, on, off, on, off, then yes, that's really an inefficient way to operate. And I've made that argument as well. So you're right. If you're doing short draws, the efficiency drops like a stone. So if you want to have that long shower, an hour-long shower, the on-demand water heater is going to be an efficient way to do that. If you're, well, one of the worst places for on-demand is in a restaurant where they have those sprayers when they're doing the dishes, and they spray the dishes, it goes in the machine, spray the dishes, goes in the machine. So every 2 seconds, a quick little couple seconds, or even not even a second long spray, on, off, on, off. That kills the appliances, because now they're starting, stopping, kills them, and the efficiency is not good. So good point.
Yeah.
Cameron asks, on a storage buffer tank, how do you set the working temp of the boiler and the turn on / shut off of the Aquastat?
So how do you
set
turn
the
the boiler
working
on?
temp of the boiler and the
So
turn
typically we
on
would
shut
put
off?
like a system sensor inside the boiler. There'd be what's it called? Like a little port, right, for the system sensor to be put inside the buffer tank, and we could set the system for a specific temperature from the boiler. And once that system sensor relays that information to the boiler that we've met temperature, the boiler would then go back into like a standby mode or something like that. And as the heating of the loop takes water away from that buffer tank and disperses it into the loop, and we need to replenish that buffer tank, it'll tell the boiler, okay, I need to get back up to the system's temperature that we've set it for, and the boiler will come back on.
And you would set a differential in there as well.
Yeah.
So that would tell, the differential tells you, how cold it's going to get before it kicks on again. So if your set point is 140, and you want to heat it up to 140, you also put a differential in, which will tell you, how low will the temperature get before I come back on.
That's
so
right.
I get up to 140, boiler shuts off, and then you got to set your differential. Okay, well, once it drops down to 120 or 110 or whatever, that's when I'm going to kick on again and bring it back up to 140. So you're going to set your set point and also your differential.
Which again helps with the cycling that we just spoke about, right? With the
Yeah.
So we don't want, the whole purpose of that is to prevent the cycling of the boiler coming on constantly.
Yeah. There's a lot of controls built into these boilers that can help you to really minimize that short cycling, and I find that's one thing that a lot of people don't take advantage of, and that's one of the things that can really greatly impact your system efficiency. So you want to really understand the controls and maximize all of the features that can minimize that short cycling. You want to take advantage of those as much as possible.
Agreed.
Harvey's asking, or no, sorry, Chris, do you have experience in applications with combi boilers with air to water heat pumps doing heating and domestic hot water? Is there a reason why you would choose combi over a conventional boiler?
Air to water heat pumps, not so much.
No. Doing heating and domestic hot water? No. Is there a reason why you would choose combi over a conventional boiler?
Again, the main reason to choose a combi over a conventional boiler, and I would assume if you're doing domestic, a conventional boiler with an indirect tank to do domestic. So the advantage is space savings. You're going to save space with a combi, and if you're replacing, like Matt talked about earlier, if you're doing a replacement where you might have had a gas-fired furnace and you've got a hot water heater in a mechanical room, you've got limited space. Well, if I'm going to replace those and I want to switch to a hydronic air handler because it's softer, more comfortable air heat, then a combi can do that, because I'm replacing the furnace with an air handler, so I'm not changing the footprint there. My water heater is going to the space my water heater is in, I'm going to put my combi in that space. So I'm going to do three things: heat my air, do my boiler water heating and do my domestic water in that same footprint. So I don't have room probably to add an indirect. So I'm going to use a combi. Now, if I'm just doing a boiler to do my air handler and I'm doing a domestic water heater separately, then I would use a conventional boiler. But I don't see a lot of people doing that. They'd probably just stay with their furnace if that's the case.
Yeah, agreed. Yeah.
What do you think of combi boilers that have a built-in 14-gallon indirect?
Love that idea. I want to see more storage built into combi boilers. Absolutely. Matt?
Yeah, no, I like the idea too. And like I said earlier, I think that we'll probably move closer. I think we'll come around back to that because again, it takes up the same footprint essentially.
Yeah.
I would say that the reason that those are probably not installed as frequently as just the regular combi is price considerations.
Price
Right?
and size. They're a little bit bigger
Yeah.
and heavier.
They're bigger and heavier. Yeah, they're heavier. So it's a little bit more difficult to get them and sort them out in the mechanical room, get them maybe down steps and things like that. But
I
yeah,
find it interesting they specifically said 14 gallon because 14. I guess he's got one in mind, but I think that storage is important, and I think Matt and I talked when we were off screen about most of the combis, the wall hung combis that don't have storage, use plate heat exchangers to do the domestic. So there's virtually no storage in a plate heat exchanger. They're extremely efficient and they heat up very quickly in a very small space, and that's the appeal of them. I would like to see more manufacturers maybe going to a shell and tube type design, which is in effect a little mini indirect tank. You've got a small storage and even 2 gallons. A 2-gallon storage with a coil in it to heat your domestic, to me, solves a lot of these problems. It gives you that little tiny bit of storage, which now lets you put a recirc port on there and you can do your recirc. It gives you that little bit of a head start. It eliminates the cold sandwich kind of effect when you're doing on-demand heating. So it solves a lot of the problems. If there's any manufacturers listening, I go back to your shops and look if you can design some of these combis with a little shell and tube in there, a little mini indirect in that tank. It doesn't have to be 14 gallons. It can be 2 gallons, and that will make a big difference.
yeah.
What do you think, Matt?
No, I agree, and I think you should start just designing combis.
Maybe if it was, maybe if I was younger.
Yeah.
Just if you recall that question I asked about the temperature setting, and it had to do with the Aquastat.
Go back to that one then. Yeah. Sorry.
Just sorry, the person came back on boilers with a buffer. If you set the boiler temp high, you will have loss of efficiency of the boiler, but if you set it low, then your buffer should be lower. The example is if you set your boiler on 140, the maximum buffer should be about 120. Still, the 20-degree or less delta T makes the same short cycle again on the boiler side.
There's not enough information really to say, it depends on your application. Like what temperature are your emitters running at? Are you running rads that are high temperature? Are you running inflow? There's a lot of variables that we'd need to know about, but buffer tanks give you the ability to have a bigger delta T on that. So you can actually lower, one of the nice things about a buffer tank is you can let that, you've got lots of stored energy there. So you can let the return water get colder before you kick your boiler on to help that boiler's efficiency. So, I'm not understanding completely the question there and there's a lot of variables that would have to be understood because, if I'm doing, like I say, cast iron rads or, copper fin baseboard heating, as opposed to, in-floor heating, there's a huge range in my set point temperature. So my buffer tank is going to have to be set, and I would typically run my buffer tank temperature based on outdoor reset. But it really depends on every application. So, do I need 140-degree water? Do I need 130? Do I need 150? Could be any number of temperatures. And I'm not tied to a 20-degree delta T on that. I don't have to, the stratification in a buffer tank can be such that I can have 140, 150-degree water temperature at the top, and I can have as low as like 90, 100, 110 at the bottom where I'm getting my return water from. So I can have quite a delta T within my tank, a lot of stratification in that tank. And when that water at the bottom gets cold, that's what's coming back to my boiler. So my boiler efficiency, the efficiency of a boiler is aided in many ways with the addition of a buffer tank. It helps prevent the short cycling, and it also helps the boiler to get that cold water return more often.
And if you're concerned as well with the return to the heat exchange to the boiler, you can also play around with like variable speed pumps and maybe slow down the water
Yep.
coming back and
Yep.
pick up efficiency that way. Like especially with the new, boilers with the fire tube heat exchangers, you can have variable flow. So if you want to slow down the water coming back to the boiler, you can pick up efficiency that way as well.
That's
Okay,
a great point.
This is going to be our last question. Is there a general rule of thumb to size a plate heat exchanger to heat domestic hot water for use with an electric water tank that has been converted to a storage tank? What is the ideal plate heat exchange construction? What is the best constructed material for the longest life? Here we go. The boiler is an NTI 200 with dual control, or do we just stick with the 33,000 BTUs per 1 gallon per minute?
The 33,000 BTUs per 1 gallon is basically, if you do the math, if you want to get a 65-degree temperature rise, you need 33,000 BTUs per gallon to do that. So that's where that comes from. A plate heat exchanger would be sized based on how much load you're doing. So if you want to do it as an instantaneous demand, you're going to have to do size your plate heat exchanger to be able to handle the BTU. So if I'm doing, a 200,000 BTU combi and I want to get 200,000 BTUs of recovery out of that, because I'm going to maximize that if I can, I'm going to size my plate heat exchanger to do, 200,000 BTUs of recovery. And that's going to have to, I want 200,000 BTUs at 65 to 70 degrees delta T. So I'm sizing my heat exchanger based on that.
Okay.
There's no rule of thumb necessarily.
We had a few more questions come in. Just quickly, would a hydraulic separator be a suitable substitute for a buffer tank?
In my opinion, no. A lot of people think they are, but the volume of most hydraulic separators is maybe on a residential size hydraulic separator, you've got 2 or 5 gallons in there. It's better than nothing, but it's not going to be anywhere close to the 30 gallons of a buffer tank. So it might prevent, if you got 2 or 3 gallons, that might extend your short cycle from 20 seconds to a minute. I'm just pulling that number. It's probably I have to calculate, but it's not going to make a big difference. Whereas with a 30-gallon buffer tank, I might extend my cycling from to 10 or 15 minutes. So
yeah, I agree with that, but I mean, at the same time, go and do the calculations, right? Like use the online resources, follow the calculation that Steve provided earlier, and if that low loss header provides 5 gallons and that's enough, then it works, right?
Yeah.
So
there's no substitute for doing the math. Exactly right.
Yeah.
And the opposite would be true though. A buffer tank does serve as a very good hydraulic separator. That's the nice advantage of a buffer tank. A buffer tank will give you air separation and hydraulic separation right there, all built into one. So that's where I would go.
Yeah.
Excellent, guys. I got to thank you very much. We're going to cut it off there. We're at almost 1:50. So thank you so much for your time today, sharing your experience and your knowledge. And I think that's it. I think before we go, I just want to let everyone remember to sign up for the air to water heat pump webinar. I know there were a few questions with respect to heat pumps. So this is where you'll find the answers to that one. And also that breaking news, Modern Hydronics Virtual Summit coming in March. Stay tuned for that. That's all we have for today. So I want to thank again Steve and Matt for their time, and thank everyone who joined us today. I hope you had a great experience. Please let us know. Send in the emails.
Thank
Bye
you.
for now.
It was fun.
Thanks, Matt. Thanks, Doug.
Thanks, guys.